Hello guys, welcome back to Backend Horizon, and today we're gonna talk about one of Java collections, set, and we're gonna talk and make some examples. Today I'm gonna try a new format. As you can see here in the screen, I have Java on the left and Kotlin code on the right. So we're gonna try to implement the examples on both languages, and please let me know if you like this format. Kotlin, it's becoming more and more popular. Um, of course, it's already very popular with Android development, but it's also become very popular in backend development. So that's why I think would be nice to cover both languages. Okay. Before we start with our example, let's take a quick look in a overview doc that I put it here. Um, Keep in mind that set it's interface in Java. So as you know, we cannot implement interface. So this means that we need to choose our implementation for the set interface to have in our collection. There are multiple implementations of the set interface, but these three are the most common ones. The first one is HashSet, LinkedHashSet, and TreeSet. The big difference of a set doesn't matter of the three implementations that you choose compared to array list is that doesn't matter the set that you choose, it will not accept duplicate elements. Okay. We were gonna create some examples with the three implementations, but it's good to keep in mind the difference between them. A hash set, it's the fastest one. It's very fast to add, to remove, and to check if an element exists in a collection, but it doesn't keep any order on the items that were inserted. Okay. A linked hash set, it's very similar to the hash set, but it keeps some order, but only in the insertion order. And as you can see in the name, both HashSet and LinkedHashSet, they are an implementation of a hash table in the background. Okay, so HashSet doesn't keep any order, and LinkedHashSet keeps the insertion order. So the orders that so item by item, they will be sorted based on this. Okay, and we have a tree set that is implementation of a tree. That is the slowest one. It's very slow to add, remove, and to check if an item exists in this collection. But for the other hand, the big advantage of TreeSet is that it keeps order, not only the insertion order, but order based on a criteria that we define. So in our example could be based on an alphabetical order, based on the product name, or based on a price, whatever you need. But this impacts the performance of the other operations, right? So now let's do some examples together. So in order to start, I will first create a list of products. I will do the same in Kotlin. Okay, so we have two lists for now. In order to create a set, we can do in Java a set of a product, and let's say that I want products that I want to buy, right? So to buy. So if we open set, as I said, set is an interface. So we cannot create an instance of an interface. We need something that implements this interface, right? So the first example that we're gonna do is we're gonna create a new hash set. And when we create a hash set in Java, we can add this list of products in a few ways. And we could, for example, add one by one, like this. But we can also initialize our hash set with a list of products. So I could get these products and pass here in the constructor. Okay, so now I have this list of products plus this another apple here. But remember that sets, they don't keep duplicates. All right, so what we're gonna do is let's print out this hash set that we have. So what I'm gonna do is I'm gonna iterate over it. So yeah, product from products, yes, yeah, AI help us again. So you're gonna print the name and the price. So I'll say that this product costs this price, right? Okay, so let's execute this. Let's see the output. Yeah, let me push a little bit here. And okay, we have our products printed. So apple, orange, banana, bread, meat, and milk. And as you can see, even though we added apples twice, it's not here. It's just once. Because sets don't keep duplicates, right? So when you see this kind of situation, you already can think that, okay, this is very useful. You can be, for example, in a situation that you have a list of products. You can have your own list, of course, in some situation, and you wanna remove the duplicates, right? This is very common. So you could initialize a hash set with your list, like we did here, and this automatically will remove the duplicates. Cool, very cool. Let's do the same now in Kotlin. And now with Kotlin, what we can do, we can get to buy, and we can get this list of products and transform into a hash set. Just keep in mind that Kotlin is a bit different. If you try to create a hash set, let's say hash set of, and try to pass these products in the constructor, as we did here with Java, the type is gonna think that this is a hash set of list of products. So it's a little bit different, okay? Something that you could also do is, instead of having a list here, we could already have directly a hash set of products. And voila. Here in Java, what we would need to do is, okay, get this and put here. It also works, and yeah, a little bit cleaner, right? Now we can also add a new product. So let me also change this to be the same, to buy. So to buy, add a new apple, and let's print this. So products in product. I wanna, okay, so product name with product price and gonna be costs. And we should have a similar output. Yes, apple, orange, banana, bread, milk, and no duplicates. Nice. With Kotlin, there is also another thing that we can do. Let's imagine that you have this list here and you don't want to accept any other item to be added. What we also could do in Kotlin is, if you enforce the interface set here, product, you will see that the add method, it's not available anymore. So in other words, we made this collection immutable. So you can't add another items. You can see that even here we have duplicates. So if we run, it's gonna filter out, and that's fine, but we can't add items later. So you see that the add method, it's not available. So this means that when we don't enforce this interface here, yeah, you see that the method is available. What it means is that we are using the mutable set, not string products. So when we don't enforce the type, what is happening in the background is that we are using a mutable set. So we can manipulate this collection, and it's possible to add more items later, right? So just keep this in mind. If you want to be immutable, just enforce a set here, and you cannot change anything else. I will remove this when we don't need it for now. Also, something okay, important to point out is that probably you already noticed is the fact that even though we don't have duplicates, both in Java and both in Kotlin, as we saw, hash sets, they don't keep any order. So you can see that the items here, they are like randomly ordered. We don't have any duplicates. They are all here, but we don't have any order. So if that fits your case, fine, HashSet would be probably the best choice for you, since like we saw before, it is the fastest ones to add, remove items, and etc. But you need to keep in mind that it doesn't have a specific order, so this cannot be a problem for you in order to use a HashSet, right? Let's explore a little bit more. Let's remove an item, and we have 3 apples here, right? So we added apple 3 times. Let's also remove it. Oops, there is a semicolon missing here. Okay, so you can see that, okay, we removed apple here, and we don't have any other apple in the output. Would be the same in Kotlin. Okay, fine. Both operations very fast to do it, but there is a very important thing in the remove method that you need to keep in mind. If I come here in Java and say that remove it 0, so position 0 in this case, and do the same here in Kotlin, you will see that we have 2 different things. We have a warning in Java and a compilation error in Kotlin. The reason is Kotlin is a bit more strict, so what he's complaining here, it's because of the type. If you look at the warning, the error, it's saying that the type inference failed. But we don't have that in Java. We have a warning. But if you're trying to remove this based on position, you're wrong. We cannot do that. Of course, this is very common in lists, in arrays, but you cannot do this in a set collection. We can only remove based on the object that we desire, not based on position. It's not possible to remove based on position. That's why we have these 2 errors here. Even though we have a compilation error in Kotlin, if my hash set, it was an integer hash set, we would not have this, and probably you would be introducing a bug, because we will try to removing the zero object from the set and not position 0, because we don't have position here. Okay, so just keeping this in mind, it's not possible to remove based on positions. Okay, so another thing that sets do very well, and we can check if an item exists in our collection. So let's do that first in Java. So what we're gonna do is let me see, I wanna product, no, sorry, it's a boolean, does it exist, and we will do to buy contains apple. Let me just comment this, and yeah, it does exist, and we're gonna print Java. Yeah, it does exist. Okay, if we add that remove again, so by remove apple, now it doesn't exist anymore. Great. Kotlin, same thing. Yeah, let's remove the apple object again. Does it exist? Yeah, contains product apple. Does it exist? Very similar. Yeah, false. And if you remove the removal function, now exists. Yeah, so that's one of the best things in the HashSet, right? This operation to check if our object exists, it's very fast. Great. Okay, now let's say that you want to check if apple exists in our collection, but you don't have the entire object. You just have the string apple. So this is a little bit more complicated. Of course, if your hash set, it was a hash set of string, that would be pretty straightforward, right? We would just check, okay, to buy contains string apple. That will be straightforward. But let's imagine that you are looking for an object like we are doing here, and I don't have the price. I just want to look based on the name. So in order to do this, this is not the ideal operation for sets, because this will force us to iterate over the entirely collection in order to find our object. Okay, so what we're gonna do is we're gonna do raw found and to buy. Yeah, AI helping us a lot again. And you see that, okay, find the object with name apple, and we're gonna have the object returned here. And I think it's good also to point out that here below you can see that local val found is it the type product with question mark. So this means in Kotlin that this is optional. So maybe this was found, maybe these were not. So we could treat this somehow, and we could, for example, say that, okay, if I don't find anything, I want to throw away exception, product not found. And now you will see that we don't have question mark anymore. And we will have our apple. And we can also do this in Java. It's a little bit more verbose. So what we're gonna do is we will get to buy, and we're gonna do a string, and yeah, we need to filter the product name, that is equal Apple. We're gonna get the find the first, or else return a null. I think that's sufficient. And maybe okay, yeah, because we remove it here. You see that's working. Yeah, let's execute again. And okay, product is here. Almost forgot to mention, guys, that another solution for this problem, that if you need to look for an object that you don't have the entire object, in our case, we want to look just based on the name. And another possible solution is to override both the equals and the hash codes. So you can see that in our example, what we are saying is that we're gonna find our object based only the name. So, and for that, we need to override both the equals and the hash code in our record and in our data class. And even though when we do our look, and when we check if an object exists or not in our set, even though, for example, for Apple, we say that the price is 15, which is not really true here, but we have the name, right? If we execute this code, we're gonna see that it's gonna say true, because in both in our equals and our hash code, we are saying that the name is the only criteria to find this object in our set. Okay, but you need to be careful, because overriding the equals and the hash code can have another implications in your project. So be careful with this. I think we have like a good overview, right, about HashSet and what is good to use and what is not the strength. Now, let's talk about the next one, that is LinkedHashSet. So LinkedHashSet is very, very similar to HashSet. But remember that I said that with LinkedHashSet, we have some ordering, right? So I can implement here a LinkedHashSet. The implementation, it's basically the same thing as the HashSet, but what we're gonna see now is a bit of ordering. Okay, so you can see that even though we have 3 apples, we only see apple once, that is in the beginning. Banana, orange, milk, bread, meat. You can see that it's the same ordering as it was inserted. And of course, ignore the duplicated ones. That's the biggest difference between HashSet and LinkedHashSet. You're gonna have order or insertion. Let's do the same here. And we're gonna have like a linked set of, and again, it respect the order. Apple, banana, orange, milk, bread, meat. Yeah. And I also forgot to say it. We can also check for the size of the collections, right? Yeah, to do size, and the same for Kotlin. You can also do this with HashSet. Size 6, yes. And Yeah, I think that's pretty much about LinkedHashSet. It has ordering based on or based on insertion order. Okay, so now we're gonna see another implementation a little bit different, right? Remember that I said that HashSet and LinkedHashSet, they are implementation of a hash table. And now we're gonna see TreeSet. And TreeSet is a bit different because it uses a tree as an implementation. And the biggest difference is that with TreeSet, we're gonna have order, but not only based on the insertion order, but we're gonna have a continuous order. Okay, so let's do first our implementation here in Java. So TreeSet. Yeah, same thing. You can accept the order in the constructor, and let's execute this, and this is gonna fail. Yes, it fails. So let's take a look in the error, exception the main thread, blah blah blah, cannot be cast to class Java comparable. And the reason of this, it's because TreeSets, they have a requirement of implementation of the comparable interface. Because remember that I told you that with TreeSets, we're gonna have a continuous ordering, right? But we need to specify of, okay, how do I order this? What do I use to order this? Are we gonna order this based on the name? Are we gonna order this based on the price? So that's why we need to implement the comparable interface. So let's implement comparable. Implement method, compare. Let's say that we want an alphabetical order. So this name compared to the other name. In this case, we implemented this in the product itself. And now, yeah, voila. We have apple, banana, bread, mad milk, all that again. Still no duplications, but ordered based on the names. Nice, right? Yeah, we could always say, okay, I want based on the price. So price compared to other price. And we're gonna have this, yeah, now ordered based on the price. And let's add more items here. And yeah, banana. Let me put new items, blueberries. Yeah, milk, no, chocolate milk. Chocolate milk. 3.5, whatever, right? So we have that ordered, and you see that we have it ordered. Doesn't matter if it was the items already initialized by the constructor, and also the ones added later. So you see that TreeSets, they keep balancing our collection all the time. Doesn't matter if it was in the beginning or added later. It keeps a constant balance based on the criteria that we chose. That in this case is the price. That's why we need to implement the comparable interface, so we know how to balance this. But this is also the downside of a TreeSet, right? Because this constant balance that it needs to be done, it's not that fast like HashSet or LinkedHashSet on do the other operations like add, remove item, because this constant balance that we need to have in the tree. Okay, and let's do the same in Kotlin, and we need to say that is a sorted set. And we also need to implement the comparable. Implement member. Yeah. Yeah, let's also do based on the price. Yeah, let me also add these items here. And yeah, I think we also should work as in Java. Yes, we have our ordering based on the price. Nice. You can also implement this comparable also in the collection itself. So let me do something a bit different. So what I'm gonna do, I'm gonna change this to to a list of. This will be products, and we're gonna and we can also have a mutable set. I will have like a hash, sorry, ordered, sorted set of product. And what we can do, we can have the comparator here. The compare. In our case, I will remove the optionals here and return I want based on the price. Yes. And we can remove this one from here. So we initialized our sorted set of, that is our TreeSet in Kotlin. And instead of having the comparable interface implemented in the data class, we're gonna have this implementation here in the collection itself. And what we're gonna do now is let's get this, and yeah, that's also another method, right? Added all. So basically we can pass a list and add a list into our set. We also have this method in Java. And I guess this should work. Yes, it's working. We can also do the same. Let's remove this from here. And I will move this list. And our TreeSet will have the comparator. Yes, return. Yeah, it's the same thing. And we will have, yeah, that ordered again. Okay, nice. Well, actually, we didn't add the items, so added all products. Yes. Now we should have the rest of the list also there. Yes. Okay, I guess that's it. Let's do a quick recap again. So we talked about the set collection. As I said 100 times, I think, you cannot have duplications in a set. And we took a look in the three main implementations of set: HashSet, LinkedHashSet, and TreeSet. There are more, but this probably would cover 99% of the case. Okay. And HashSet, very, very fast to add, remove, and check if object exists in that collection, but it doesn't keep any ordering in your items. LinkedHashSet, very similar. It keeps the order based on the insertion in the collection. It's a little bit slower than HashSet in the operations, but you will at least have some ordering, all right? These two are hash table implementations, and we have another one that is TreeSet, that is a tree implementation that is much slower in the add, remove, and check operation, but on the other hand, it keeps a constant order on your items based on your criteria, based on the comparable interface that you implement. Okay, I think that's it for today. Thanks a lot for watching, and please give me some feedback. Tell me if you like this format of having Java and Kotlin code side by side. It helps me a little bit to see if you guys are liking this format, and I hope this was very informative for you. And thanks for watching. See you in the next one. Bye bye.